Now we are going to move the player game object. First, let's think through how we want this player game object to behave. We want to have the sphere roll around on the game area, bump into walls, stay on the ground, and not fly off into space. We want to be able to collide with our collectible game objects and pick them up when we do. This requires physics. To use physics, the game object needs a rigid body component attached. To attach a new component, we must first select the game object we want to attach the component to. In this case, we will select our player game object. Then we can either choose the component menu and select Physics Rigid Body, which would attach this component to the game object we have selected, or use the Add Component button in the inspector, choosing Physics Rigid Body. Either way, this attaches the rigid body component to the selected game object. If we choose to, we can rearrange the order of the components on the game object using the Context-Sensitive Gear menu in the upper right of the component. Doing this has no effect on the performance of our game. However, having a consistent order to the components on our game objects may help us speed up our development by keeping or maintaining an organized project in hierarchy. Don't forget, you can collapse or expand the component view by clicking on the component's title bar. We should note that whenever we do this, this will also toggle the relevant gizmos for that component in the scene view. Now we need to get the player object moving under our control. To do this, we need to get input from our player through the keyboard, and we need to apply that input to the player game object as forces to move the sphere in the scene. We will do this by using a script that we attach to the player game object. First, let's create a folder in our project view to hold our script assets. In the project view, click on the Create menu and choose Create Folder. Rename this folder Scripts. Next, let's create a new C# script. To create a new script, we have some choices. We can choose Assets Create to create our new C# script, or we can use the Create menu in the project view. But what might be more efficient in this case would be to select the player game object and use the Add Component button in the inspector. The Add Component menu contains the selection New Script. This allows us to both create and attach a script in one step. First, let's name this script Player Controller. We can choose the language of the script, which will be C#, and then click on Create and Add, or simply hit the Return or Enter key to confirm our selection. Unity will create, compile, and attach this script to our selected game object. We should note, this way of creating a script will create that script asset on the root or top level of our project view. We will need to move the asset into the scripts directory in order to maintain an organized project view. If we select the script in our project view, we see a preview of the script asset in the inspector, but this text is not editable. Let's open the script. We can do this a number of ways. When we are inspecting a game object using the script, we can use the Context-Sensitive Gear menu. We can double-click on the script asset in the project view, or we can use the Open button in the inspector when we have the script selected in our project view. This will open our script in our preferred script editor. First, let's remove the sample code provided in the base script. Next, let's think. What do we want to do with this script? We want to check every frame for player input. And then we want to apply that input to the player game object every frame as movement. Where will we check for and apply this input? We have two choices: Update and Fixed Update. Update is called before rendering a frame, and this is where most of our game code will go. Fixed Update, on the other hand, is called just before performing any physics calculations, and this is where our physics code will go. We will be moving our ball by applying forces to the rigid body. This is physics, so we will put our code in Fixed Update. What code do we need to write? We know we need input, but how do we find out more? There is a shortcut in MonoDevelop that searches the Unity API. On the Mac, it's Command plus single quote, and on the PC, it's Control plus single quote. Select the item you want to research, in our case, input, and hold down the Command or Control key and type the single quote button. This search brings up every reference in our documentation related to input. Select Input at the top, Interface into the input system. This brings up the page on Input. This is the page on the Input class. We use this class to read the axes set up in the Input Manager and to access multi-touch and accelerometer data on mobile devices. We read the text on the top of the page to understand how to use the class. In our case, to get input from the player on all platforms, including mobile devices. Under the description is a list of class variables and class functions. The class variables hold information like the number of touches in touch count, or a reference to the default gyroscope with gyro. The class functions do something for us. In our code, we will be using input-get-access. When we find the item we want, we click on the link to bring up a page on the function or the variable. Let's look at input-get-access. This page includes the signature of the function, a description of the function, and code snippets showing how to use it in Unity's JavaScript and C#. We will be using C#. For more information on the Input Manager and input-get-access, see the lessons linked below. We will be using input-get-access in a very similar way to the code snippet. Let's return to our script and write our code. Float move horizontal equals input-get-access horizontal. Float move vertical equals input-get-access vertical. This grabs the input from our player through the keyboard. The float variables move horizontal and move vertical record the input from the horizontal and vertical axes, which are controlled by the keys on the keyboard. Our player game object uses a rigid body and interacts with the physics engine. We will use this input to add forces to the rigid body and move the player game object in the scene. To know more about how to apply forces to the rigid body, let's check the documentation. Type rigid body into our script. Now select rigid body and hold down the Command key on the Mac or the Control key on the PC and type single quote. Again, this brings up a page with the search term rigid body. We want to click on rigid body. This brings up the rigid body page. If we want to apply force to our player game object, we need to do something. So let's look at the functions available to the rigid body class. We read the descriptions until we find the one we want. In this case, let's choose add force. This adds a force to the rigid body. As a result, the rigid body will start moving. Click the link and we go to the page on add force. We can see the signature of the function at the top of the page. This signature tells us we need a vector 3 and an optional force mode to add force to our rigid body. What is a vector 3? For more detailed information on vector 3, please see the information linked below. But in simple terms, the vector 3 holds 3 decimal values in one container. This makes it easy for us to move around and use values for things like a force in 3D space, which requires a value for force on each of the x, y, and z axes. Or to describe a rotation, which would also require a value for each of the x, y, and z axes. All of our documentation pages are linked together. If we were to click on vector 3, we would be taken to the documentation page for vector 3. The same is true for force mode, monobehavior, and rigid body. Below the description are snippets that show us how this function could be used. Note the second signature for add force below the first. The descriptions are the same, but in this case we can use add force with either a vector 3 or 3 float values for x, y, and z. The next concept that we need to cover is how to get a hold of, or how to reference, different components on our game objects. We are writing a script called Player Controller, which is attached as a script component to our player game object. From this script, we need to add force using the rigid body component. we want to access that component from this script. There are several ways that we can do this, but in our case, we will cover only one of the main ways of accessing another component on the same game object. We will create a variable to hold this reference in our script, and we will set this reference in the start function. We see this here in the code snippet. Public rigidbody RB creates a public variable with the type of rigid body called RB to hold the reference to the rigid body we want to access. In start, the reference is set by using the code getComponentRigidBody. This will find in return a reference to the attached rigid body if there is one. All of the code in the start function is called on the first frame that the script is active. This is often the very first frame of the game. Finally, in fixedUpdate, the attached rigid body component is accessed through the variable named RB with rb.addForce. So, in our script, we need to write private rigidbody RB to create the variable to hold the reference. And in a new start function, we need to write RB equals getComponentRigidBody. In fixedUpdate, let's use the simplest version of rigidbody addForce, one that simply uses a vector3, and we will leave the force mode at default by omitting it from our code. So, in our script, we need to type rb.addForce and then some vector3 value. Now, how do we get our two float values into a vector3 value? Let's create a new vector3 variable called movement. This will be equal to a new vector3 that is made up of an x, a y, and a z. The x, y, z values will determine the direction of the force we will add to our ball. What is our x value? That would be move horizontal. With this, our left and right keys will add force moving the ball to the left or right. What is our y? 0. We don't want to move up at all. What is our z value? That would be move vertical. Now we use movement, a vector3 value, in RB add force as RB add force movement. Let's save this script and return to Unity. We check for errors in our footer or the console, and there are none. Good. Let's test what we've written. Hit play, and by using the keys set up in the input manager, the ball moves in the scene. But it's very slow. This is too slow to be playable, but the basic concept works 100%. To stop testing, leave play mode. Let's return to our code and create a tool that will give us control over the speed of the ball. We need to multiply our movement by some value. We could simply enter that value here in our script, but if we ever needed to make any tweaks or changes, we would have to return to our scripting editor and change the value in the script and then recompile. This takes time. The solution is to create a public variable in our script. Let's create a public float called speed. By creating a public variable in our script, this variable will show up in the inspector as an editable property. When we use a public variable, we can make all of our changes in the editor. We then multiply movement by speed. We now have control over our movement value from inside the editor. Let's save these changes and return to Unity. When we return to the editor, we can see our player controller script now has a speed property. Let's set this property to 100. Now, enter play mode. Whoa, way too fast. But changes are fast too. Exit play mode and change the value to 10. Hit play. That's a little better. Congratulations! We can now move our character. In the next assignment, we'll talk about how to move the camera.